Welcome to Civil Engineering Licensure Examination Reviewer for practical questions on mathematics. Litton's Problematical Recreations, Part 2. Problem number 16. In a fast Major League Baseball game, pitcher high and outside managed to get by with the minimum number of pitches possible. He played the entire game, which was not called prior to completion. How many pitches did he make? The correct answer is 25 pitches. In order to avoid pitching the last half of the ninth inning, he had to be on the losing side. Thus he must have allowed at least one run, which would have required at least one pitch. 24 more pitches were necessary to produce 24 outs. Problem number 17. Determine the next three terms of a sequence 12, 1, 1, 1. The correct answer is 2, 1, and 3. The sequence represents the number of chimes of a wall clock which strikes once on the half hour. Problem number 18. What is the least number of links that must be disengaged from a 23-link chain so that any number of links from 1 to 23 can be obtained by taking one or more of the pieces? The correct answer is 2, the 4th, and the 11th. Problem number 19. The set A contains the integers 0, 4, 5, 9, 11, 12, 13, 14, 19. The set B contains 1, 2, 3, 6, 7, 8, 10, 15, 16, 17, 18. Place 20 and 21 in their proper sets. The correct answer is 20 is in set A and 21 is in set B. Set A contains number with an even, set B with an odd number of letters in their literal representation. Problem number 20. State University won their first football game of the season 17-0. Though they scored no safeties, they managed to score more points each quarter than they had scored in the previous quarter. What were State's quarter scores? The correct answer is 0, 3, 6, and 8. Without safeties, only one answer is possible: 0, 3, 6, and 8. The third period score could come either from a touchdown or 2 field goals. The fourth period score had to come from a touchdown plus a 2-point conversion. Problem number 21. A chemist has 3 large test tubes and a beaker with 54 cc of elixir. Using the test tubes and ingenuity only, how can he retain 50 cc in the beaker? The correct answer is by using eye-level test. By using eye-level test, he divides 54 cubic centimeters between 2 test tubes, returning 27 cubic centimeters to the beaker. Then he divides 27 cubic centimeters among the 3 test tubes, returning 18 cubic centimeters to the beaker. Next he divides the 9 cubic centimeters among 3 test tubes, returning 6 cubic centimeters to the beaker. Next he divides 3 cubic centimeters among the 3 test tubes, returns 1 cubic centimeter to the beaker and combines contents of 2 test tubes, leaving 2 cubic centimeters in one. Finally, he measures out 2 cubic centimeters from the beaker to an empty test tubes, leaving only 50 cubic centimeters in the beaker. Problem number 22. Using only the symbols on the right, 3 valid equations are possible. Give yourself full credit if you get one. The correct answer is 6 is equal to 3 factorial, omega raised to the power of 6 is equal to 1, and omega raised to the power of 9 is equal to 1. Where omega is the standard notation for one of the complex cube roots of 1. Problem number 23. How many colors are necessary for the squares of a chessboard in order to assure that a bishop cannot move from one square to another of the same color? The correct answer is 8 colors. It can be done with 8 colors, 1 for each row, since a bishop move always involves a change of row. That no smaller number will do is seen from the fact that the main diagonals can have no other color repeats. Problem number 24. A neat computer programmer wears a clean shirt every day. If he drops off his laundry and picks up the previous week's load every Monday night, how many shirts must he own to keep him going? The correct answer is 15. He must pick up 7 shirts to tide him over until the following Monday. Hence he must deposit 7 shirts each Monday. Counting the shirt he wears on Monday, the required total is 15. Note that he cannot get by with only 14 by exchanging his Monday shirt for clean one and turning it into the laundry, as he will be caught short the following Monday. Problem number 25. The passengers on an excursion bus consisted of 14 married couples, 8 of whom brought no children, and 6 of whom brought 3 children apiece. Counting the driver, the bus had 31 occupants. How is this possible? The correct answer is 18 children and 8 couples. Problem number 26. Very few people are aware of the growth pattern of Jack's beanstalk. On the first day it increased its height by 1/2, on the second day by 1/3, on the third day by 1/4, and so on. How long did it take to achieve its maximum height? 100 times its original height. The correct answer is 198 days. Every day it increased its height by 1/2 of its original height. In 198 days, it reproduced its height 99 times and was therefore 100 times its original height. Problem number 27. Tom, Dick, and Harry played a round of golf, each ending with a total of 72 strokes. Each pair competed against each other in match play, most holes won. Tom beat Dick, and Dick beat Harry. Does it follow that Tom beat Harry? The correct answer is no. For example, Tom could have shot 3, 4, and 5 followed by 15 fours, Dick 4, 5, and 3 followed by 15 fours, and Harry 5, 3, 4, followed by 15 fours, in which case Tom would end 1 up on Dick, Dick 1 up on Harry, and Harry 1 up on Tom. Problem number 28. 6 boys on a hockey team pick a captain by forming a circle and counting out until only 1 remains. Joe is given the option of deciding what number to count by. If he is second in the original counting order, what number should he choose? The correct answer is 10. Any counting interval from 1 through 9 will result in another team member's selection. Joe will be captain if he chooses 10. Problem number 29. Show, with a simple example, that an irrational number raised to an irrational power need not be irrational. The answer is, let a equal square root of 2 raised to the power of square root of 2. If a is rational, it is the desired example. On the other hand, if a is irrational, a raised to the power of square root of 2 is equals to 2 is the desired example. Problem number 30. Depicted above are the 22 cities of Puevijay and their road connections. Can you devise a continuous tour which visits each city exactly once? The correct answer is no. There are 5 columns of cities. Since cities in odd-numbered columns connect only with cities in even-numbered columns and vice versa, a tour must alternate between cities of each type. But there are 10 cities in even-numbered columns and 12 in odd. Hence a continuous tour is impossible. Problem number 31. A jigsaw puzzle contains 100 pieces. A move consists of connecting 2 clusters, including clusters of just 1 piece. What is the minimum number of moves required to complete the puzzle? The correct answer is 99. The number holds true regardless of the manner in which the puzzle is assembled. The proof is trivial. We start with 100 pieces and end up with a single cluster. Each move reduces the total number of clusters by 1. Hence 99 moves. Problem number 32. There are 3 errors in the statement of this problem. You must detect all of them to receive full credit. The correct answer is, the misspelling of errors and receive are, of course, the first 2 errors. The third error is simply that there are only 2 errors in all.